Okay, so today we're going to look at section 3.1. It's all about functions. And when we talk about functions, we look at the definition. It's basically just an equation with the stipulation that for each x value substituted into the function, there is exactly one y value for the answer. And I think that's kind of, fairly logical for the most part, that we're used to putting a number in for x and getting one answer for y. But there are certain equations where that does not happen. So what we do is we say from here on out in this book, we're only dealing with equations that are considered functions. So if I put 1 in for x here using the function notation, f of x is x plus 3. That means that 1 is the value I substitute in for x, add 3 to get 4. So 4 is the only answer we'll get when x is 1. So this means x is 1 here, y is 4. No different than what we've been doing with equations, except for the notation. So again, that's your notation, whether it's f of x, g of x, h of x, whatever letter they use, it's the exact same thing as the y value. So when we use the notation f of x or g of x or whatever, we are claiming that the equation is a function, as I stated before, because not all equations are functions. So keep in mind that the number inside of the parentheses is the x value. So if I have f of 3, and that's just how we say it, f of 3, x is 3. G of negative 5, x is negative 5, etc. So first we want to evaluate our functions. So what we do is, if we want to find f of negative 2, we substitute negative 2 in for all x's. Now, this is a good time for you to practice using your calculator, making sure that your square is on the outside of the parentheses. You can enter this in exactly as it appears here, keeping in mind that this is different than this. This is subtraction operation. If you're identifying a negative number, you've got to put the minus sign that is in the parentheses. Okay, so I go ahead and simplify this expression here. Negative 2 squared is 4 times 3 is 12 plus negative 2 is 10 minus 5 is 5. So what we end up with is x is negative 2, y is 5. Okay, so that's our first example. F of 0, and again, when x is 0, we can also, state that this is the y-intercept. So, this allows us to graph these things. We're still finding points. Nothing's really changed. It's just a different notation. So f of 0 is 3 times 0 squared plus 0 minus 5. And maybe many of y'all figured out that you really didn't even need to substitute it in, because when I put in 0 for these x's, they go away. So here is my y-intercept. X is 0, y is negative 5. X is 4. So if I want to find f of 4, I again substitute the 4 in for all my x's. And use your calculator. No need to risk messing up with your order of operations, because you need to be careful. Do not multiply then square, and your calculator will take care of that for you, because you should square the 4 to get 16, then times the 3 to get 48, plus 4 is 52, minus 5 would be 47. The last one down here, we got the fraction. I can't do anything without at least doing something with the fraction. is f of 1/2. Now, there's a couple ways to do this. In math, we really like to keep things as fractions unless we can convert it to a decimal that is terminating. We don't want to round, especially when we're substituting it into the equation. But remember, this is the same as f of 0.5. So you can do this either way if you're using your calculator. So if I substitute using the fraction, I just put 1 divided by 2 inside parentheses, square it, plus 1 divided by 2 minus 5. That's how you can enter it in. Okay? You can totally do it all in one step on your calculator, and you can also use the 0.5 in there as well. So once I do this, I'm going to square that 1/2 to get a 4th times 3 to get 3/4. And what you end up with is f of 1/2 is going to be negative 3.75. Okay, so, do either one, but just remember you can always enter fractions into your calculator. And when you do 1 divided by 2, it's going to look like a fraction. So that'll maybe help you understand that you're correct there. All right, so that's kind of just evaluating functions, just like we put numbers into equations, just a different process. You're never solving for f. Always remember, you are substituting and simplifying. All right, so let's go to the next page here. And your next page, we're going to be doing another equation. The only difference here now, we're going to, just put letters in to where we're not going to get a number as an answer. So we can substitute anything in for x that we want to. So to find f of a, whoops, crooked little equal sign there. We just substitute the a in for all x's, and really nothing changes except that instead of x squared, we just have a squared. We have a, and we have the 1. So you're not doing anything with this. Stop here. Some of y'all are going to want to factor and do all kinds of crazy stuff. F of a equals this, and you're done. If I substitute in negative a, what happens when I square negative a? Well, it just makes it positive a. So this does not change. It remains 2a squared. This becomes minus 3a because 3 times negative a is minus 3a and minus 1. Now for this next example, I've obviously not given us enough space. So I will do this in class, possibly when we go over this section. But it's just a matter of substituting an expression in for your x, and once we square it, it does take up quite a bit of room. Don't want you to have to worry about cramming it all in there. But I just hope you get the understanding that you're substituting these expressions in there. So I will hold that one for class just to give us more room on the board so we can write it out. So that's pretty much what we're going to be doing with these functions right now in this first section, is just substituting and simplifying. Don't factor, don't try to do anything else with it. Substitute and simplify. Okay, the next topic is what we call domain. Now, we've already kind of done some things with domain when we've done our equations where we solved that had fractions, and we would get certain numbers in the denominator, and it would give us a 0. Therefore, that equation had no solution. Also, with square roots, there were certain numbers that you could not substitute back into the square root because you couldn't get an answer. So when we talk about domain, it is the set of all x values that can be evaluated for a function. So for some functions, the domain can be the set of all real numbers, and that's that funny looking R. And what we mean is that x can take on any value, and we can get a real answer for y. For other equations, there may be restrictions on what x values we can substitute into the equation. And we have two possibilities at this time. So just think about what I'm saying again. Sometimes when we are doing like what we're doing up here and substituting numbers into this equation, that's what we talk about when we talk about our domain. What can we put in here for x? What numbers can we use? And in this equation here, I can put anything in there for x I want to. Okay? But there are two restrictions right now where we can't substitute anything we want to into the equation. So one is an expression with x in the denominator of a fraction, because you cannot have a 0 in the denominator. The second possibility is if we have x under an even root, because you cannot have a negative under an even root. You can't put it into your calculator, you get an error, it's undefined. So what we're looking for are these two possibilities for any of these equations we come across, for any of these functions. If we don't have either one of these two, then the domain is the set of all real numbers. So if I want to look at the domain for this one here, f of x is x minus 3. Well, it's not a fraction. It's not under an even root. So therefore, my domain is, we can write it this way, x is an element of the real number system, or we can say all real numbers, or the other way to do it is negative infinity to positive infinity. So those are three ways that you can say your domain is anything you want it to be. X can be any number. I can subtract 3 from any number. Part B, same situation. I do not have a fraction. I do not have a even root. So therefore, my domain is all real numbers, or however else you want to write that. In part C, we got a problem. We've got a fraction. We've got x in the denominator of a fraction, and the value that would give us a 0 is 1. Because x minus 1 equals 0, if I solve for that, I get x is 1. So therefore, my domain is x cannot be 1. Now, in the back of the book, they might do it like this. They probably will do it like this. And this kind of means the same thing. It's saying that x can be negative infinity to 1, not including 1, union with 1 to positive infinity. So this covers all numbers but 1. The other way is just to say x cannot be 1. Okay, so sometimes you got to solve. Oftentimes you can just look at it and say, I know x can't be 1 here. Okay, either way. Part D. Here we have a square root. And this seems to be, in my experiences for students, the toughest of all the domains. For whatever reason it just is. In order to be able to take the square root of a number, whatever underneath this square root must be 0 or bigger. So logically, if x were 9, I get 9 minus 9, which is 0, and I can put that into my calculator. So anything 9 or bigger would be what we need under that square root. But the way we find that, because you may not always be able to see it, we say x minus 9 must be greater than 0. So solving, we get x is greater than or equal to 9. So then my domain is 9 to infinity. Okay, so just try to remember the difference for when we're dealing with something under a square root or fourth root or whatever, and when we're dealing with something in the denominator of a fraction, like we have here in part E. So what I know x squared minus x can't equal 0. So then what I do is I go ahead and solve to see what's going to give me 0. And you may be kind of stuck here, but always remember GCF. So I can factor, because in order to solve a quadratic equation, it must be equal to 0, and we must have two factors. So x is 0 or x minus 1 is 0. So our two values that are going to give us 0 in the denominator are 0 and 1. So my domain is x cannot be 0, x cannot be 1. Okay, so that's your domain. So, and we're going to do plenty of these next time we meet. Hopefully, we'll get better at this with more practice, but it is a topic that seems to give students trouble. So just remember, your domain is your set of all x values. We haven't talked much about the range, but I will talk about that in class. But just before we discuss it in class, your range is your set of all y values. So we'll look at some of those in class. Now our last topic are sums, differences, products, and quotients of functions. So what we can do is we can be given a scenario where we are asked to take f plus g of x, and that means to add the two functions together. If we're given a number here, that means we put the number in each function and then add them together or subtract them or multiply them or divide them. So if you're not given a number, you just take the functions and add them together. Combine like terms if you can. If you're given a number, then you put the number in and evaluate it. So let's look at a few of these. So for part A, if I wanted to take f plus g of x, I know that is f of x plus g of x. Whoops. So f plus g of x, well, f of x is x squared, g of x is x plus 2. I can remove my parentheses, and there's nothing to do but just list those terms there. So that's what f plus g of x is. The next rule, how about if we want to subtract our functions? Well, this is f of x minus g of x, which means I take x squared, and again, make sure you put that second one inside parentheses because that minus sign is distributed to both the x and the 2. Next, to multiply. If I wanted to take f times g of x, well, that is f of x times g of x. And so I take x squared times x plus 2. X squared times x is x cubed. 2 times x squared is 2x squared. And I'm done. The last operation we can do with functions is f divided by g of x. So that's going to be f of x over g of x, which is x squared over x plus 2. There's nothing else I can do with that, so I'm finished. So that's what we do when we are adding, subtracting, multiplying, dividing functions, just when we're asked in this certain notation here, and when x does not take on a value. Now, let's say we were given a value. Let's say we wanted to take f plus g of 4. Well, just by the rule that we have up there above, that's going to be f of 4 plus g of 4. So I take 4 squared plus 4 plus 2, because remember, f of x was x squared, g of x was x plus 2. So that's 16 plus 6, which is 22. So this time I can get a numerical answer. For f minus g of 4, I take f of 4 minus g of 4. And you'll see that you're going to get the same number every time. 4 squared minus 4 plus 2. So that is 16 minus 6, which is 10. So anytime you're seeing these sums, differences, products, quotients of functions, just take it and go directly by the rule. Okay? F minus g of x is f of x minus g of x. So f of g of 4 means I'm going to take f of 4 times g of 4. Well, I know this is 4 squared times 4 plus 2. So this is 16 times 6, which is 96. Last is the division, the quotient. So I'm going to take f of g of 4, which is f of 4, divided by g of 4. So that's going to be 4 squared over 4 plus 2, which is 16 over 6, which reduces down to 8/3. Okay, so that's everything in 3.1. Again, we will do some more examples, some more evaluating to give you a little more practice at this stuff when we meet. So we will see you at our next class period.